So let's start with the problem. You have an exponential equation, 3 to the x equals 9. We know x is 2. But the question is, what are we raising x to? What are we raising 3 to get 9? So we know that x has to be 2 so that we have 3 squared equals 9. The way we can reframe the question is the exponent that I need to raise the base to is 2. And we refer to that as the logarithm of the number 9 to the base 3. So the base is the same, whether we're talking about an exponent or we are talking about a logarithm. The base is the same. So that x here is called the logarithm of 9 to the base 3. In other words, the logarithm, which we shorten to log of 9 to the base 3 is 2. And so the official definition is here. We say that this number y is the log of n to the base b if and only if b to the power y is n. And therefore, log to the base 3 of 9 or log of 9 to the base 3 is 2 because 9 is 3 squared. For instance, 27 is 3 cubed. So it means that the log of 27 to the base 3 is 3. 64 is 4 cubed. So log to the base 4 of 64 is 3. Of course, the base can change. So if we do log to the base 64, log to the base 16 or 64, or log of 64 to the base 16 is what? So let's call it y, means that 64 is 16 to the power y. So we write everything in terms of 4. So 4 cubed is 4 to the 2y. So y is 2y is 3, y is 3 over 2. That leads us to the fact that log 64 to the base 16 is 3/2. And so the exponential form is the other side of the coin. This outside is the log form. So you notice the bases are the same. So here, this is our base. 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 And your task would be to convert them into log form. Just as we have laws of exponents, we have laws of logarithms, and you will find out that the proofs mimic one another. You notice that, and I'll just write out what the exponential ones are so you see what's going on. The base is the same, right? So remember, you had some a to the m times a to the n equals a to the m plus n. So you notice that this here is my m, this here is my n. So effectively, same idea. Assume that my log to the base a of capital M is small m. So let this be true, and let log to the base a of n be small n. So what's log to the base a of m times n? Right, it's some number. Let's say, call it y. So it means m n is e to the y. But what do we know from our logs? Well, we know that m is a to the power m, small m. N is a to the small n. So it means we're going to have a to the small m, a to the small n equals a to the y. From the rules of logs, this is a to the m plus n. So y is m plus n. And so you realize that we're using the laws of indices, converting them into logs and getting the exact numbers that we have here. So this works out. The second one follows the same proof. Third one follows the same proof. And you will notice that this is a copy of the statement a to the 0 equals 1, and this is a to the 1 equals a. And just as if we go back to the rules of indices where I said that a to the m equals a to the n, if and only if m equals n, if we skip forward to the log equation, you find that, again, we have the same thing. Log to the base a of m equals log to the base a of n, if and only if m and n are the same. So same idea. And so just like that, we will see how we will use these to work that out. We already saw something like this in the pre-test. So we'll go into some more detail as we go along. So in the last part of this lecture, we will talk about radicals or sets.